The Swedish embassy in Ukraine just confirmed a massive transfer. 26 additional Archer systems have been handed over to the Ukrainian armed forces, likely part of Sweden's 20th military aid package. This isn't just a top-up, it's a game changer. We aren't just talking about a specialized experimental squad of 8 anymore. Ukraine is building a full-scale Archer fleet, but this sudden influx of hardware makes the critical questions in this video even more urgent. With the fleet tripling in size, the logistics and maintenance challenge just got 3 times harder. So let's find out if this spaceship is actually ready to handle the workload. For the last 30 years, Western military doctrine has been built on a seductive promise. The promise was that technology would replace mass. We were told that one smart bomb is worth 1,000 dumb shells. We were told that comfort keeps crews alive, that computers eliminate human error, and that the future of war looks like a clean, precise laboratory. We were wrong. When the Russians crossed the border in 2022, they didn't bring a laboratory. They brought a meat grinder. They brought mud that swallows tanks whole. And into this hellscape, NATO poured its most advanced, expensive, and complex machines, the fully automated, climate-controlled digital marvels designed to fight a theoretical war that no longer exists. But after 4 years of the most brutal combat in modern history, we have to ask the uncomfortable question: did we over-engineer ourselves into a corner? Is a multi-million-dollar robot actually better than a rusted iron cannon that just works? Today, we are stripping away the marketing hype to rigorously analyze the 2 most advanced artillery systems on the planet, the German PzH 2000 and the Swedish Archer. We are going to find out if superior technology is actually the answer, or if it is a trap. Hit like and subscribe to support the channel. Thanks. We are used to the heavy hitters of the free world coming from the usual suspects. When we talk about raw firepower, we look to the industrial might of the United States. When we talk about precision engineering, we look to Germany. When we talk about sheer volume, we look to the legacy of the Soviet Union. But there is one weapon system currently operating in the Donbass that defies all the stereotypes. It comes from a nation that hasn't fought a war in over 200 years. A nation we associate with flat-pack furniture, safety-conscious family cars, and aggressive neutrality: Sweden. We are talking about the Archer. If you look at the glossy brochures, this isn't just a howitzer, it is a spaceship on wheels. It is the fastest, most automated, most futuristic artillery system on the face of the Earth. It was promised to be the sniper of artillery, a machine so advanced it would make the American Paladin look like a musket from the Civil War. But war has a way of taking beautiful theories and dragging them through the mud, literally. Because right now, in the forests of eastern Ukraine, the best artillery system in the world is facing a crisis that no one talked about in the press releases. It is a crisis of fragility. A crisis where a simple engine failure turns a multi-million-dollar robot into a useless brick. We are going to look at how 8 Swedish Archers went to war, how they stopped a tank assault that should have been impossible to stop, and why, shockingly, only a fraction of them are actually able to fight today. Is the Archer the future of warfare? Or is it a technological dead end that can't handle the grit of a real fight? Let's find out. To understand the Archer, you have to understand the paranoia of the Cold War. For decades, Sweden sat in a terrifying geographical position. They were neutral, yes, but they were also the speed bump between the Soviet Union and the North Atlantic. They knew that if the Red Army ever decided to move, they would come with thousands of tanks, waves of infantry, and a storm of artillery that would black out the sun. Sweden has a small population. They could not trade lives for lives. They couldn't build a trench line and hold it with massed infantry. Their doctrine was built on one word: movement. They needed to hit the enemy, bleed them, and vanish before the Soviet counter-battery radar could even lock onto their position. They needed a weapon that didn't require a battalion of men to operate. The project began in 1995. It moved at what we might call a Swedish pace: methodical, slow, obsessive. It took nearly 20 years of tinkering to get it right. By 2023, Sweden had 48 of these machines. Half were in service. The other half were sitting in cold storage, gathering dust, waiting for a political deal to send them to Norway that never happened. But history has a sense of irony. Instead of guarding the fjords of Scandinavia, 8 of these sleeping giants were woken up and sent to the most intense artillery duel on the planet: Ukraine. When the Archer finally arrived in Ukraine's 45th and 43rd Artillery Brigades, the crews didn't know what to make of it. They were used to the Soviet Tu-S7 Pion, a 203mm monster that looks like a locomotive and hits like a sledgehammer. The Pion is brute force. It is loud, dirty, and manual. The Archer? The Archer is an alien. Let's look at why the world fell in love with this machine. First, the speed. In modern artillery warfare, time is life. When you fire a 155mm shell, modern counter-battery radar detects the projectile in flight, calculates the trajectory, and pinpoints your location before your shell even hits the ground. You have, at best, 2 minutes before return fire rains down on your head. The Archer laughs at 2 minutes. Imagine a 30-ton armored truck tearing down a highway at 70 kilometers per hour. It slams on the brakes. In 30 seconds, the stabilizers deploy, the gun elevates, and it is ready to fire. Bang, bang, bang. It fires 3 rounds in roughly 12 seconds. And here is the magic trick. Before those 3 rounds even impact the target, the Archer is already folding up its gun. Within 30 seconds of the last shot, it is back on the road, moving away. It is a phantom. By the time the Russian counter-battery fire hits the coordinates, the Archer is a mile away, and the crew is listening to Spotify in the air-conditioned cab. Second, the automation. In a standard American Paladin, the inside of the turret is a sweatbox. Men are heaving 40-kilogram shells, shoving propellant charges, shouting over the noise. It is physical, exhausting labor. In the Archer, the crew of 3, driver, commander, and operator, sit in the armored cabin. They never touch the ammo. They never smell the propellant. It is more like playing a video game than fighting a war. The crew never has to leave the armored cabin. The shells are pre-loaded into a magazine, just like bullets in a rifle. This allows for the Archer's party piece: multiple round simultaneous impact. The computer is so smart that it can fire 4 shells at 4 different trajectories. The first one is fired high, into the stratosphere. The second, a bit lower. The third, lower still. The fourth, almost flat. The computer calculates the flight time so that all 4 shells land on the Russian bunker at the exact same millisecond. For the Russian soldiers on the receiving end, there is no warning. No initial explosion to make them take cover. Just instant, total annihilation. This capability makes the Archer a surgical tool. It isn't a sledgehammer like the Pion. It is a sniper rifle with a 50-kilometer range. The Ukrainian crews call it the Crocodile because of its long, green, snout-like barrel resting over the cab. And they absolutely love the comfort. The 43rd Artillery Brigade took these machines and integrated them into a new kind of warfare. They don't operate in batteries of 6 guns lined up in a field. That is suicide in the age of drones. They operate as lone wolves. They drive with an escort car carrying electronic warfare jammers and a guy with a shotgun to hunt drones. They sneak into position, they strike, they vanish. We have footage of the crews. They have named their guns after their Swedish instructors: Matilda, Alice, Hugo, Ulf. It's a touching tribute. In a way, they are fighting alongside us, one soldier said. Matilda destroys the occupiers, and the combat record is terrifyingly impressive. There is a story from the Battle of Kursk. The Russians tried to break the line with a massive armored fist. 18 tanks, a nightmare scenario for light infantry. 3 Archers were in the sector, just 3. They synchronized their fire. They used the MRSI capability. They turned the lead tanks into burning wrecks, blocking the road. Then they dismantled the rest. Jurist, a former judge who used to fight corruption in courtrooms and now fights tanks in mud, described the feeling with a level of adrenaline that you can't fake. You say in the radio, Matilda, fire. Amanda, fire. Hugo, fire. It's better than sex, really. It's longer, and much better. He pauses, realizes what he said, and adds, "Don't show my wife. Cut it." This is the peak of the Archer's reputation. Fast, lethal, a tank killer. a machine that makes its crew feel invincible. But every hero has a tragic flaw, and the Archer's flaw is hidden deep inside its engineering.
Here's our Archer, totally frozen up. We're in the middle of this damn field waiting for an enemy Lancet. Here are the anti-aircraft guys. One of my buddies is scanning for the Lancet in the air.
After months of high-intensity combat, a disturbing statistic emerged from the Ukrainian General Staff: 34%. That was the readiness rate of the Archer fleet at one point. Out of 8 units delivered, only 2 or 3 were actually combat capable at any given time. The rest were in the repair shop. Why? It wasn't the gun. The cannon itself is a masterpiece of metallurgy. It wasn't the computer software. It was the truck. The Archer is built on a Volvo A30D articulated hauler chassis. Essentially, it is a modified mining dump truck. On paper, this is brilliant. It means you have excellent off-road capability, and you can buy spare tires at a civilian heavy machinery dealer. But a mining truck is designed to haul dirt, dump it, and go back for more. It is not designed to carry a massive, vibrating, recoiling artillery system through deep mud 24 hours a day, while being hunted by drones. The problem is the integration. In a traditional tracked howitzer like the Paladin or the German PzH 2000, the engine drives the tracks, and a separate auxiliary power unit, APU, or hydraulic system runs the turret. There is redundancy. In the Archer, the chassis engine is the heart of everything. The Volvo engine powers the hydraulics that lift the gun. It powers the generator that runs the targeting computer. It powers the autoloader. Here is the simple, brutal logic of the Archer's failure. If the engine dies, the weapon dies. If the chassis breaks an axle in the mud, and the Ukrainian mud is notorious for snapping axles, the Archer is not just immobile. It is a paperweight. You cannot hand crank the autoloader. You cannot manually traverse the turret efficiently, and the chassis is breaking. The complexity of the system is its undoing. The sensors that allow for that 30-second deployment are delicate. They don't like constant vibration. They don't like dust. They don't like the damp, freezing Ukrainian winter. It's a tricky system. Compare this to the Bodana, the Ukrainian-made truck-mounted howitzer. The Bodana is a sledgehammer. It's a gun bolted to a Tatra truck. It's manual, it's crude, it doesn't have an autoloader. But if the truck breaks down, you can still fire the gun. If the electronics fail, you can use optical sights and hand cranks. The Archer offers no such forgiveness. It is an all-or-nothing machine. When it works, it is the god of war. When a sensor fails or the Volvo engine coughs, it is a 30-ton target waiting to be destroyed. This fragility creates a massive burden on the human element. Training to operate an Archer is not like learning to drive a car. It's like learning to fly a jet. The Ukrainian crew spent 2 months in Sweden with 0 days off. Wake up at 6 a.m. training all day, one soldier recalled. What they taught us in a month and a half normally takes 6 to 10 months. This means the crews are elite. They are highly skilled professionals, but there are very few of them. If one crew member gets sick or wounded or transferred, the efficiency of the unit drops. You cannot just grab a guy from a mortar team and throw him into the Archer's commander's seat. He wouldn't know which button starts the firing sequence and which one reboots the ballistic computer. And then there is the maintenance. There are only 8 Archers in Ukraine, with more promised but slow to arrive. This is a zoo of logistics. You need specific Volvo parts. You need Swedish electronics technicians. You need specialized lubricants. When you have 200 systems, like the M109 Paladin, you can cannibalize one to fix another. When you have 8, every loss is a catastrophe. This scarcity forces the commanders to be conservative. They can't risk the Archers on high-risk missions as often as they would like. They are firing less, not just because of ammo shortages, which are critical across the entire front, but because they have to preserve the barrel life and the chassis mechanics. There's plenty of work for Archer, the commander says. But in terms of firing, we're running low. We're prioritizing only the most important targets now. They are hunting high-value assets, counter battery, enemy command posts. They are not wasting Swedish precision steel on a lone infantryman in a trench. So, as we stand here today, 4 years into a war that has consumed the stockpiles of the entire Western world, where does the Archer stand? It is a paradox. In terms of pure performance, ballistics, speed, accuracy, it is likely the best wheeled howitzer in existence. The capability to fire 4 rounds and have them land simultaneously is a game changer. The safety of the crew in that armored cabin is second to none. The stories from the Battle of Kursk prove that in the hands of a skilled crew, 3 Archers can do the work of a whole battalion. But the 34% readiness rate is a warning siren. It teaches us that in a long, grinding, dirty war, reliability is a weapon. A gun that shoots 90% as well, but works 99% of the time is often better than a gun that shoots 100% perfectly, but spends half its life in the garage. The Archer is a Formula One car rallying on a dirt track. It is magnificent, but it is fragile. The reliance on the chassis engine for all combat functions is a design choice that makes sense for peacetime Sweden, defending good roads near maintenance hubs. In the mud of Donbas, miles from support, it is a liability. The Ukrainians love them. They treat them like royalty. They name them like family members. But they also hold their breath every time they turn the key, hoping the Volvo engine roars to life one more time. As we look to the future, the US Army is eyeing the Archer to replace its aging M109 ES. They see the automation, they see the speed, but they should look closely at the mud of Ukraine. The Archer has proven that wheeled artillery can dominate, but it has also proven that you cannot engineer your way out of the basic realities of mechanical wear and tear. That is the trade-off of modern warfare, the balance between the silver bullet and the iron sledgehammer. For 20 years, this machine was the undisputed king of artillery. On paper, the German PzH 2000 is a technological marvel, fully automated, armored like a tank, and comfortable enough to operate in slippers. But military history is full of marvels that failed the moment they hit real mud. Critics said it was too complex, too heavy, a diva that would break down in a war of attrition. So did German over-engineering fail in Ukraine, or did it redefine what artillery can do? Today, we separate the marketing brochure from the brutal reality. This is the ultimate review of the PzH 2000. When military analysts discuss self-propelled artillery, the conversation almost invariably gravitates towards one machine, the Panzerhaubitze 2000. Often described as the Rolls-Royce of howitzers or a studio apartment on tracks, this German-made behemoth represents the pinnacle of Cold War engineering, tailored for a high-intensity conflict in Europe. But for decades, its reputation was built largely on firing range tests and low-intensity peacekeeping missions in arid climates like Afghanistan. It was a theoretical champion that changed dramatically with the Russian invasion of Ukraine. For the first time, the PzH 2000 was thrown into the environment it was designed for, the muddy, freezing, and artillery-saturated battlefields of Eastern Europe. It faced a peer adversary capable of massive counter-battery fire, electronic warfare, and drone swarms. This review seeks to answer a fundamental question. Does the complexity of German engineering hold up when the war demands not just precision, but brutal endurance? By analyzing operational data, maintenance logs, and tactical shifts observed over years of combat in Ukraine, we can finally separate the marketing brochure from the battlefield reality. We will dissect its firepower, mobility, protection, and the logistical nightmares that come with operating the most advanced artillery system in the world. And before we dive deep into the topic, please support the channel by subscribing. It allows us to grow. Thank you. To understand the PzH 2000, one must first understand its scale. Weighing in at nearly 57 tons, with add-on armor, it is heavier than many main battle tanks, including early T-70s. This mass is not accidental. It is the result of a specific design philosophy that prioritizes crew survivability and sustained operations above all else. Inside, the vehicle contrasts sharply with its Soviet counterparts like the Tu-S7 Pion or the Tu-S19 Emsta-S. While Soviet doctrine viewed the crew as replaceable components of the machine, German engineers designed the PzH 2000 with long-duration missions in mind. The interior is pressurized, climate-controlled, and spacious enough to allow the crew to stand upright. This is not merely a luxury in a chemical, biological, or nuclear NBC environment, or simply during the freezing Ukrainian winter. This environment reduces fatigue. A less fatigued crew makes fewer calculation errors, fires faster, and stays combat effective longer. The layout accommodates a standard crew of 5: commander, driver, gunner, and 2 loaders. However, the high degree of automation means the system can theoretically be operated by just 3 people, or even 2 in extreme emergency scenarios. This redundancy is a critical feature in a war of attrition, where personnel shortages are a constant reality. The heart of the PzH 2000 is its 155mm L52 chromium-lined barrel, developed by Rheinmetall, but the gun is only as good as the system feeding it. The PzH 2000 utilizes a fully automated shell loading system with a pneumatic flick rammer. This mechanism manages the 60-round magazine located in the center of the chassis. In artillery duels, speed is life. The PzH 2000 claims a burst rate of 3 rounds in roughly 9 seconds and up to 10 rounds in nearly 1 minute. Operational experience in Ukraine has confirmed these metrics are achievable, provided the system is well maintained. This rapid fire capability allows for the execution of the multiple round simultaneous impact tactic. MRSI is the artillery equivalent of a time-on-target strike performed by a single gun. By altering the elevation of the barrel and the propellant charge for each shot, the PzH 2000 can launch up to 5 shells on different trajectories that all arrive at the target at the exact same instant. For Russian infantry or light armor in the open, this is devastating. There is no warning whistle of the first shell to prompt them to take cover. The entire barrage lands simultaneously. Unlike the shells, the propellant charges, modular charges, are loaded manually by the 2 loaders. This hybrid approach allows the crew to quickly adjust the range by adding or removing charge modules. However, it also introduces a human variable into the rate of fire, particularly during prolonged engagements where physical exhaustion sets in. The transition from Soviet-era systems to the PzH 2000 was a culture shock for Ukrainian crews, moving from manual optical sights and analog calculation circles to the PzH 2000's MICMOS digital fire control computer was compared to upgrading from a vintage sedan to a starship. The onboard ballistics computer handles every variable: wind speed, air temperature, propellant temperature, barrel wear, and even the Earth's rotation. This automation allows for a lay and fire capability that is unmatched. The PzH 2000 does not need to deploy outriggers or spades to stabilize itself before firing. It can stop, receive coordinates via data link, fire a burst, and move again in under 2 minutes. This capability is the cornerstone of shoot and scoot tactics in a battlefield environment teeming with counter-battery radars like the Russian Zoo Park one, and loitering munitions. Staying static is a death sentence. The PzH 2000's ability to be miles away from its firing position before its shells even hit the target has been the primary factor in its relatively low loss rates, compared to towed artillery like the M777. However, this high-tech approach has a downside. The system is intolerant of abuse. Delicate sensors and miles of wiring are susceptible to the damp, muddy conditions of the Donbass. Error codes became a common headache for crews used to fixing equipment with a sledgehammer and a wrench. The learning curve for maintenance personnel was steep, requiring specialized laptops and diagnostic software rather than brute force mechanics. One of the most surprising revelations from the Ukrainian front has been the PzH 2000's resilience against modern threats, particularly drones. While many Western and Soviet vehicles are now routinely fitted with slat armor, cope cages, and anti-drone screens, the PzH 2000 often operates without them. Why? The answer lies in its structural engineering. The turret is covered with hedgehog armor, rubber thorns designed to scatter the jet of shaped charge warheads from cluster munitions. The propellant charges, which is the most volatile part of the ammo load, are stored in the rear of the turret, separated from the crew by a high-strength blast door. In the event of a penetration, blowout panels on the roof vent the explosion upwards, saving the crew and often the vehicle itself. This design philosophy stands in stark contrast to Russian autoloader systems, like the T-72 or Tu-S-19, where the crew sits directly on top of the ammunition. There are documented cases in Ukraine where PzH 2000s took direct hits from Lancets. And not only did the crew survive, but the vehicle remained mobile enough to retreat for repairs. The effectiveness of the PzH 2000 is multiplied by the advanced ammunition it fires. High explosive rounds offer a respectable range of 30 kilometers. Ukraine has utilized the full spectrum of NATO 155mm advancements. Perhaps the most lethal round in the arsenal is the German DM702, known as SM Art 155. This is a sensor-fused munition. Once fired over a target area, the shell releases 2 sub-munitions on parachutes. These sub-munitions spin, scanning the ground with infrared and radar sensors. Upon detecting a tank or armored vehicle, they fire an explosively formed penetrator, EFP, through the thin top armor of the target. Operational reports indicate that a single PzH 2000 firing smart 155s can halt an entire armored column in minutes without ever having a direct line of sight. This capability forces Russian armor to disperse and hide, breaking the momentum of assaults. For high-value targets like command posts or electronic warfare stations, the GPS-guided M982 Excalibur offers surgical precision up to 40 to 50 kilometers. While Russian electronic warfare, jamming, has reduced the efficiency of GPS-guided rounds over time, they remain a potent tool. The Italian-German Volcano rounds extend this range even further, potentially up to 70 to 80 kilometers, allowing the PzH 2000 to strike deep into the Russian rear, rivaling the reach of HYMARS rockets, but at a fraction of the cost per shot. It is not all praise, however. The war in Ukraine has exposed the PzH 2000's Achilles heel, its maintenance intensity. The system was designed for the Cold War doctrine of fight furiously for a few days, then rest. It was not designed for the artillery barrages like in the Battle of Bakhmut or Avdiivka, where a single gun might fire 300 to 500 rounds in 24 hours. This intensity leads to rapid barrel wear and overheating of the autoloader mechanism. The error message culture of the German computer system meant that initially, the gun would refuse to fire if sensors detected parameters slightly outside of optimal norms. Ukrainian crews, out of necessity, learned to bypass some of these safety locks or reboot the system mid-battle. Furthermore, the PzH 2000 is a logistical heavyweight. It requires high-quality fuel, specific lubricants, and cleaner propellant charges than older systems. Repairing significant damage often requires shipping the massive 57-ton vehicle all the way to specialized workshops in Lithuania or Germany, removing it from the battlefield for weeks or months. This logistical tale is the primary argument critics use when comparing it to simpler systems like the French Caesar or the Czech Dana. The chassis of the PzH 2000 shares components with the Leopard 1 and Leopard 2 tanks, powered by a massive MTU 881K, a 500 diesel engine, producing nearly 1,000 horsepower. On paper, it is agile. In reality, its weight is a limiting factor. In the Ukrainian mud season, 57 tons is a liability. While tracked vehicles generally fare better than wheeled ones, like the Caesar or Bodana, the PzH 2000 can still bog down. Recovery requires heavy armored recovery vehicles like the Bergapanzer III. Additionally, many rural bridges in eastern Ukraine are not rated for such weight, restricting the tactical mobility of the system and forcing commanders to plan routes carefully. However, when the ground is solid, the PzH 2000 is surprisingly fast, capable of road speeds up to 60 kilometers per hour. This speed is vital for the scoot part of its survival strategy. Before 2022, the combat record of the PzH 2000 was limited to ISAF operations in Afghanistan. Dutch and German crews used them effectively against Taliban positions, but the nature of that conflict was vastly different. It was asymmetric warfare. The PzH 2000s acted as sniper rifles, firing a few rounds a day from static, heavily fortified bases, FOBs. They were never under threat of counter-battery fire or drone strikes. The lessons learned in Afghanistan, mostly related to air conditioning and dust filters, were insufficient for Ukraine. The high-intensity usage mode, considered a theoretical emergency scenario in NATO manuals, became the daily routine in Donbass. The fact that the system did not catastrophically fail under this pressure is a testament to the over-engineering typical of the German defense industry. An interesting footnote in the history of the PzH 2000, relevant to understanding its raw power, is the Monarch project. In the early 2000s, the German Navy attempted to mount the PzH 2000 turret onto a frigate, the Hamburg. The idea was to replace naval guns with a system capable of firing standard, cheaper Army ammunition at naval targets, while the recoil dampening system worked and the gun could fire from the deck. The project was ultimately scrapped. The corrosion from salt water and the complexity of integrating Army software with naval radar proved too costly. However, this experiment highlights the sheer versatility and modularity of the turret design. It is a self-contained weapon system that was literally too powerful for the ships of that era. To truly evaluate the PzH 2000, we must place it alongside its peers in Ukraine. The Crab uses a chassis licensed from South Korea, K9 Thunder, and a British turret design. It is simpler, slightly more rugged, and easier to repair. The Crab is the workhorse, while the PzH is the precision instrument. The Caesar is a truck-mounted gun. It wins on strategic mobility and ease of maintenance, but offers zero protection for the crew and lacks the 360-degree turret traverse and tracked mobility required for mud. The Paladin is the veteran. It is reliable and numerous, but significantly outranged by the PzH 2000, L39 barrel versus L52 barrel, and fires much slower due to lack of full automation. The PzH 2000 has proven itself to be the undisputed heavyweight champion of self-propelled artillery in the Russo-Ukrainian War. It combines the firepower of a battery into a single vehicle, offers tank-level protection to its crew, and delivers precision that fundamentally changes the geometry of the battlefield. However, it is not a wonder weapon in the sense that it is invincible or maintenance-free. It is a high-maintenance diva that demands a professional logistical chain and highly trained crews. When treated correctly, kept clean and dry, as the manuals say, it dominates. When neglected or pushed beyond its limits without care, it becomes a 57-ton paperweight. Ultimately, the PzH 2000 has validated the Western doctrine of quality over quantity. One German howitzer, integrating with drones and firing smart munitions, has shown it can achieve tactical results that would require an entire battery of Soviet-era guns, all while keeping its crew alive to fight another day. In the brutal calculus of war, that survivability is its greatest asset. So, what have we learned from the German fortress and the Swedish spaceship? Both of these systems are marvels. They are undeniably superior to the Soviet-era metal they replaced. They save lives. They destroy targets with a precision that 20th century commanders could only dream of. But they also reveal a dangerous flaw in Western military thinking. We fell in love with the idea of the wonder weapon. We spent decades designing systems for a war where we would have total air superiority, perfect logistics, and short, sharp battles. We designed systems for comfort and efficiency, but we forgot about resilience. The PzH 2000 is a diva that needs a clean workshop to keep firing. The Archer is a glass cannon that needs an elite pit crew to keep moving. But war is not a workshop. War is mud and blood and chaos. In 1945, the T-34 tank defeated the German Tiger not because it was better, but because it was simpler, reliable, and there were thousands of them. Today, Ukraine is teaching us that while it is nice to have a touchscreen fire control system and a climate-controlled cabin, the most important feature of a weapon is simply availability. A perfect Archer that is sitting in a repair shop with a broken axle is infinitely less useful than an obsolete M109 Paladin or a crude Bodana that is out on the line firing shells right now. The future of war isn't just about high-tech sensors. It's about building machines that can be fixed with a hammer, fueled with dirty diesel, and operated by a soldier with 2 weeks of training. Because when the high-tech sensors fail, and they always fail, you are left with just the metal. Make sure you are subscribed so you don't miss our next deep dive. To be honest, putting this video together was a bit of a marathon. Digging through the field reports for 2 different systems and trying to separate the marketing hype from the reality took a lot of late nights. We actually had this draft sitting in the pipeline for a while. But when that news broke about Sweden sending 26 more Archers, it gave us that final kick. We realized, okay, this isn't just history anymore. This is unfolding right now, and we knew we had to get this out to you immediately. So I'm really curious, how does this new deep dive format land with you? Is this detailed, comparative style something you want to see more of? And seriously, tell me what we should tackle next. Tanks, drones, electronic warfare? The comments section is open and I read everything. Thanks for sticking around, guys. See you in the next one.